In this video, we are looking at experimental and theoretical probability, right? You've probably heard about this before and seen it, right? In a nutshell, experimental probability is what actually happens during an experiment, whereas theoretical probability is what should happen in all likelihood based on how likely something is to happen. In other words, right, flipping a coin, there are two sides. So theoretically, you should get heads half of the time and tails half of the time. But if you were to flip the coin 20 times, we know that you may not get exactly 10 heads and 10 tails. And so this is the difference between experimental probability and theoretical probability. So let's take a closer look. So experimental probability is defined as a probability that is based on repeated trials of an experiment. So the probability of a given event is found with the number of times that event occurs divided by the total number of trials. So for example, this table shows the results of spinning a penny 25 times. So you're spinning that penny and it's landing on either a head side or a tail side. So again, we would know the theoretical probability here is 50%. It should be equally likely to land on both sides. But we can look at our experimental probability and it shows, right, it has landed on heads 6 times. So our probability that it lands on heads will be equal to 6 out of a total of 25 times. And again, we can find 6/25. We multiply by 4 there to get a percent, and we would have 24%. So the probability, experimental probability, that it lands on heads is 24%. Now, looking at our theoretical probability, when all possible outcomes are equally likely, the theoretical probability of an event is the quotient of the number of favorable outcomes and the number of possible outcomes. Okay, so let's look at an example of that. You randomly choose one of the letters shown, right? So we've got 7 letters here. Now, each of these letters is equally likely to be drawn, right? If you're just choosing one of these randomly, they're all equally likely, each of those blocks. So now we want to know, what is the theoretical probability of choosing a vowel? So if we look at these 7 outcomes, right, 3 of them, E, O, and another E, are our favorable outcomes. So the probability of choosing a vowel will be equal to our favorable outcomes, which is 3, divided by our total possible outcomes, which is 7. So the probability of choosing a vowel is going to be 3/7. So then if we take 3 and divide by 7, right, this will go on. But we can round here. So this will be about 43% theoretical probability of choosing a vowel here. Let's look at this next one. The bar graph shows the results of rolling a number cube 300 times. And we want to see how the experimental probability of rolling an odd number compares with the theoretical probability. So a number cube is just what they call dice. So we know that dice have 6 sides. So the odd numbers would be 1, 3, and 5, right? So the theoretical probability of an odd would simply be 3/6, which is 50%, right? So it's equally likely to land on an odd number or an even number. And now we want to compare that to our experimental probability. What has actually happened during these 300 rolls? So we can see, right, again, the probability of an odd will be equal to all of our favorable outcomes. So we've rolled a 1 48 times, a 3 50 times, and a 5 49 times. And that's all out of a total of 300 rolls. And then, right, we can add 50 plus 49 plus 48, which is going to be 147. So then 147 divided by 300 will give us our experimental probability here. and we get 0.49 or 49%. So in this case, our experimental probability was very close to our theoretical probability, which was 50%. Okay, now looking at this next one, a bag contains 50 marbles. You randomly draw a marble from the bag, record its color, and then put it back in the bag. The table shows your results after 30 draws. Predict the number of red marbles in the bag. Okay, so basically what we're doing here is we're going to use our experimental probability to help us predict the theoretical probability. Basically, right, so we've got 50 marbles. Now, if you were to draw a marble out, so you're doing 30 draws. If you were to draw a blue marble out 15 times, right, you could predict, okay, 50% of the time I drew a blue marble, so I could predict that half of the marbles are blue based on that experimental probability. Now we know that's not a perfect science because this is random, but that would be more likely to happen than a marble that's only in there once. So we're going to look at this one. This says after 30 draws, you got the results shown in the table, and we want to use that to predict the number of red marbles in the bag. So the probability of drawing a red one, our experimental probability, is equal to 9 out of the 30 draws so far. Okay, now 9/30ths. We can simplify that fraction to 3/10ths, which is 30%. So our experimental probability here is 30%, right? It was 30% of the time we drew a red marble. And then we know there are actually 50 marbles, so we want to find 30% of 50, right? So 30% of 50, which you could do with our percent equation, or you could set up a proportion here. 3/10ths will be equal to how many red marbles out of 50, right? Solving that way, pretty quick here, we can see you'll have 15 red marbles. Or we can do our percent equation, 0.3 times 50. You'll get the same answer of 15. So using our experimental probability, we can predict that there are 15 red marbles. Final problem here. The theoretical probability of winning a bobblehead when you spin a prize wheel is 1/6. The wheel has 18 sections. So how many sections have a bobblehead as a prize? So if the theoretical probability is 1/6 and we have a total of 18 sections, we're just solving this proportion here, right? We want to know how many of these sections have a bobblehead as a prize. So again, we're finding what B is here. And we can see since 6 times 3 is 18, 1 times 3 will be 3. So there are 3 bobblehead sections. And then part B says, if you spin the wheel 540 times, about how many bobbleheads do you expect to be won? So again, we're using our theoretical probability here to predict. So 1/6 of our sections are bobblehead winning sections, and we're going to spin 540 times. So again, right, 1/6 of the time you can win a bobblehead, and we're doing 540 spins. So let's see now how many times you could expect to win a bobblehead. So we saw our proportion. Okay, so let's do our cross products rule. 540 will be equal to 6b. Divide by 6 on both sides. And we get 90. So we could expect about 90 bobbleheads to be won if the wheel is spun 540 times.